Hey Year 7s, Mr. Herman here, and this skill is compare positive and negative fractions. This skill can be found within the fraction topics of Essential Assessment. The learning goal for this topic is to look at equivalent fractions, greater or less than or equal to fractions, ordering fractions, and splitting a number line. The success criteria is to be able to convert a fraction to any equivalent form, to compare two fractions, to order fractions in a sequential order that include negatives, and to also obtain the skills to split a number line into parts dependent on the length. There's quite a few things that you need to be able to successfully achieve for this skill. There's quite a bit involved. So in saying that, there's going to be quite a few examples that we'll be looking into. So I've taken a few examples from the Essential Assessment. And this one here is to be able to, for the first question, find an equivalent fraction to this fraction here. An equivalent just means another way of writing this fraction form. And we've got this 4 different answers. Now there's many ways that we can achieve this, especially if you're good with finding lowest common multiples and simplifying a fraction. The best way to do this is to get your calculator out. So right here I've got my scientific calculator, and what I'm going to do is I'm going to punch in 8/24 as a fraction. And what the calculator will do is it will spit out the simplified version of this 1/3. So this 8/24 is the same as getting a part, splitting it up into thirds, and caring about just one of those thirds. Now from the 4 examples, we're looking for the fraction that also simplifies to 1/3, and this is what we're going to find, because if we can find that one that simplifies to 1/3, we've found the equivalent fraction to 8/24. So 2/8, when that simplifies, gives us 1/4, so it can't be this one. 16/50 when simplified, 16/50 when simplified gives us 8/25, can't be this one. 2/6, 2/6, this is 1/3, and just to double check, 12/32 is 3/8, so it can't be this one. So this one here has to be our answer, and this is just implying that 8/24 or 1/3 is also the same as 2/6, because it's again the same as 1/3. The next question here is we're going to fill in the missing fraction in this equivalent fraction here. So right now this 36/80 can be simplified. Now just to double check, let's have a look to see what 36/80 can simplify down to. If the answer provided to you has the 9 on the top, then whatever the solution is here will be your number. So in this case, 36/80 is the same as 9/20. But there might be a circumstance where you need to work this out manually. How you do this is, say for instance, let's have a look here, and we had 9 over here. You will need to find a number that when you divide it into 36, it will give you the answer 9. So you're looking for a number, and then on the calculator you're going to type in 36 divided by some number which we don't know, and that number will give you 9. Now how you work this out is you just do the reverse process. You find what 36 divided by 9 is, and we got 9 just from here, and this will be 4. So that means if I divide 36 by 4, I should get the answer 9, which is here. Now the reason why we get this number, this is called a common divisor, is we also divide the bottom number by 4. And we found this by getting this number here on the top. When we find this number 4 here, the common divisor, we also divide the bottom by 4, and this will yield a 20. Okay, so the calculator part will be able to hopefully simplify it for you, but if you get to a number where it can't be simplified, or if you do simplify it, it's a different answer, then you can use this process here. The next question looks at inserting the symbol less than, equals to, or greater than. So there was a video that I made before that talks about these different symbols. We looked at that in probability. This is less than, this is equal, and we're used to saying equal, and this is greater than. Now a bit of a quick little mini lesson. I can say, if I look at the number 8 and the number 10, one of them is greater than the other, and we know that the 10 is greater. And how we know which symbol we use is based on this imaginary alligator wanting to bite the bigger number. In this case, because 10 is greater than 8, we write 8, and this is the less than 10. So if you read this from left to right, 8 is less than 10, and that makes sense. 8 is of course less than 10. If I wrote it the other way around and put 10 first and then 8, and I read this from left to right, again the alligator eats the bigger number, and this symbol here means greater than. So this is saying that 10 is greater than 8. And of course, 10 is going to be eaten because it's the bigger number out of the two. So now, hopefully being familiarized with greater than or less than, we're going to apply this to 2/3 and 7/9. So the only problem is 2/3 and 7/9 we can't simplify. Okay, they're the most simplified form. So in this case here, we have to find a way to get 2/3 and 7/9. We have to change this fraction here to make it say something over 9. So in this case here, 7/9, we have to change this into a 9. What do I have to multiply this 3 by to turn it into a 9? In this case, we have to multiply it by 3. 3 times 3 will give us a 9. So whatever I do on the bottom or the denominator, I also have to apply to the numerator. So 2 times 3 is 6. So 2/3 and 6/9 are the same fraction. And then from here, we can now establish which one's greater. Is 6/9 greater or 7/9? Well, 7/9 is greater because I'd rather have 7 out of 9 pieces as opposed to 6 over 9 pieces. And because of that, the alligator will eat the greater fraction in this case. So we're going to put a less than symbol, and this is saying that 2/3 is less than 7/9, because 6/9 is less than 7/9. So therefore the 2/3 is less than 7/9. Now you will get a question where it does have less than, equals, or greater to, but you run into a big problem here, because right now 3, 6, and 4/9, again, it can be simplified. This 3, 6 can be simplified to a half, but that doesn't get us to any point. So we have to find a number which is considered as the lowest common multiple. Lowest common multiple, or in other words, if I was the number 6 plus out of 0, and I walk every 6 steps, and I keep going 6, 12, 18, 24, etc., and I keep going. If I was the number 9 and I walked in every 9 steps, at what point will I meet up with one of these dots? Well, I would go to 9 first, which is here, and then I will go again to 18, which is already here. And this is why it's called the lowest common multiple. It's the lowest number because it's the first number they meet up. They will keep going and meet up on and on and on. The lowest one from this track is 18. It's a multiple because both of the numbers go into 18. So we've got the lowest, we've got the multiple, and it's common because, well, it's the same number, it's 18. So what does this mean? We have to change 3 6 to something over 18. Or in other words, 6 times what gives me 18? Well, 6 times 3 gives me 18. So I have to multiply that 3 in the top to give me the numerator, which is 9/18. Now that makes sense. 3 6 is the same as half. 9/18 is also the same as half. So we've found a common fraction, 9/18. We now have to do this for 4/9, but it's going to be a little bit different because 4/9 over something over 18. And this time we're not timesing it by 3, but we're just timesing it or multiplying it by 2. So whatever I do to the bottom, I do to the top, times it by 2, 4 times 2 is 8. And now we've got our two fractions, 9/18 and 8/18. Which one's greater? Well, in this case, the 9/18 is greater because having 9/18 is better than having 8/18 of something, depending on what the context is. I always think of chocolate. So 3 6, because 3 6 is the same as 9/18, is the greater one, so the alligator is eating the greater one. So you will read this as 3 6 is greater than 4/9. We're going to look at this question here, and this is where we have the introduction of negative fractions. We're going to drag the fractions from smallest to largest. Now, with this answer, this has already been provided from smallest to largest. Now, what's tricky about this question is that on the number line, if we were to draw a number line, we know numbers keep going in both directions. We get to negative direction over here, and then we also have the positive direction over here. And we use the number 0 as like a middle ground, not necessarily a starting point, but a central neutral point. So we know that negative numbers have to go onto the left hand side if it's from smallest to largest, and then the positive ones go to the right. But how you would actually order this is to try to find a number, a common number that can go into 3, 4, 8, and 6. Now, this is not obvious by any stretch of the imagination, because sometimes it's not obvious to get the solution. I know that the common number is 24, because I know 3 can go into 24, 4 can go into 24, 8 and 6 can all go into 24. So we can apply this process here on converting all of these fractions to something over 24 and then ordering them from smallest to largest. But the other way of doing this, especially if we know we can use our calculator, is just to convert these numbers here to decimals, so that way we can rank the decimals from smallest to largest. So in this case, 1/3 or negative 1/3. That negative button is right here. We'll press that, get our answer, and then convert it to a decimal. And this is the same as negative 0.33. So this is negative 0.33. This here, I know when converting it, is negative 0.25. This here is going to be 0.66. 6 over 8 is going to be 3 over 4, so that's 0.75. And then 5, 6. 0.83, that's right, 0.3. And now we're in this format where we've got decimals, and we can just arrange the decimals associated with the fractions from smallest to largest. Just be careful though that when it comes to the negatives over here, even though 0.33 is greater than 0.25, when we get to the negative zone, it goes this way. So the less there is of something, or the more there is of something within the negative spectrum, the less that number is. So for instance, I would rather have less of a certain chocolate bar of 0.25 as opposed to 0.33, because this is saying there's more of that negative, which is less. It's more or less, if that makes sense. So be careful of this. The greater the negative number is, the further back it goes, assuming that you're arranging it from smallest to largest. This question here has a number line that's been divided into equal parts, and we have to find out which fraction of the line is each part. So we're going to venture from 0 all the way to 1. In this case, we're just going to count up how many parts there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 parts all up. So the fraction of each line is just a tenth. This is a tenth, this is a tenth, this is a tenth, and this keeps going. If we add all of those tenths up, it would give us exactly 10 tenths, which is 1. So that needs to be our answer. And the last example that we have a look here, the number line has been divided into equal parts, just like the previous example. The only tricky part is, instead of it being a 0 here, it is now -1. So we have to be careful about how much each of these chunks represent. The first thing we're going to do is we're going to count how many chunks there are all up. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means half of 12 is equal to 6. So we have 1, 2, 3, 4, 5, 6 chunks. This number here has to be a 0. So that's a 0. Now we can just focus on the 0 to 1, because we kind of had to do a little bit of extra work. If a -1 has been thrown here, we have to find that central neutral middle spot before we can see what each chunk of this represents. And because there are 6 parts in the middle of this, each chunk represents 1/6. Even if it goes into the negative spectrum, again, each part of this represents 1/6. It's just going in the opposite direction. So a lot of students, and I've seen this time and time again, they look at this and they say, this has to be 1/12 because there are 12 parts. Not necessarily. We're trying to figure out what each chunk of these represents based on the fact that 0 is here. So the correct answer in this case is not necessarily 1/12, but it's 1/6. And that concludes this video for this lesson. Go ahead and attempt this skill, what you need to do, and I'll see you guys in the next video. Bye.